when Japanese media satellites quietly focused on a shipyard along China's coastline, clearly capturing the emerging outline of a massive hull. A question that stunned the global military observation community emerged. Why has the Chinese Navy crossed the threshold of nuclear-powered aircraft carriers with such confidence and speed, bypassing the lengthy technical validation process once cautiously navigated by the US and Soviet Union, and aiming directly for the pinnacle of global carrier technology? Recently, Japanese media, using satellite imagery purchased from a US commercial remote sensing company, unveiled to the world for the first time high-definition construction images of what is believed to be China's fourth aircraft carrier, and its first domestically built nuclear-powered carrier, the widely speculated Type 004. The photographs, taken inside a dry dock at a key domestic shipyard, revealed two massive rectangular structures measuring 14 meters by 16 meters each. While the overall hull form remains partially concealed, these structures have been professionally identified as highly likely to be the shielded compartments housing the ship's nuclear reactors. This detail, like a stone thrown into calm waters, has sent ripples of speculation about a leap in China's naval strategic capabilities. More striking is the measurement derived from the images by Japanese media. The ship's waterline width is approximately 43 meters, surpassing the 40.8 meters of the US's most advanced active carrier, the Ford-class nuclear-powered aircraft carrier. If accurate, and considering a reasonable hull length to width ratio, the Type 004 carrier's full load displacement would likely surpass the Ford-class 100,000-ton threshold. Its claim to the title of the world's largest and most powerful aircraft carrier is no longer mere rhetoric. Even more thought-provoking is its power configuration, which appears to be a leap forward. Following the lineage of American nuclear-powered carriers, the Type 004 seems to have adopted a dual-reactor layout. Given the anticipated larger displacement, the confident choice of a dual-reactor design is far from a blind imitation. It strongly suggests that China has achieved a critical breakthrough in high-power naval nuclear reactor technology. The output power and overall reliability of its single reactor are sufficiently assured, not only capable of delivering a robust speed of no less than 30 knots to this maritime behemoth, but also poised to effortlessly meet the voracious power demands of future carrier systems like electromagnetic catapults, advanced radars, and integrated electric propulsion. This leads to a reasonable inference. The domestically developed naval reactor aboard the Type 004 has achieved comprehensive performance metrics that at least match, and may even surpass in certain areas, the A-1B reactor powering the Ford-class carriers. This technological confidence forms the core foundation, enabling China to boldly embark on building a nuclear-powered supercarrier. Historically, the development of nuclear-powered surface vessels has never been achieved overnight. Even the two Cold War giants, the United States and the Soviet Union, chose relatively gradual, risk-controlled paths. The U.S. Navy's nuclear propulsion journey began with the nuclear-powered cruiser USS Long Beach, which served as a valuable maritime test platform for accumulating reactor operation experience. Only years later did this lead to the legendary nuclear-powered aircraft carrier USS Enterprise. The Soviet Union's path was more circuitous. Its technological foundation originated with the Lenin nuclear-powered icebreaker. After repeated refinement in civilian applications, nuclear propulsion systems were finally deployed on the Kirov-class cruisers. The planned nuclear-powered aircraft carrier Ulyanovsk remained unfinished until the dissolution of the Soviet Union. Their journeys clearly demonstrate that directly constructing a nuclear-powered supercarrier is a monumental systems engineering endeavor that represents the pinnacle of industrial and technological achievement, fraught with immense challenges. China, however, has chosen a radically different path. Prior to this, China had no publicly documented history of constructing or operating any nuclear-powered surface vessels. In other words, we are virtually starting from scratch in this domain, yet we have dared to aim directly at the most technically complex and systemically challenging project, a nuclear-powered supercarrier, for our very first vessel. This audacity to begin at the pinnacle demands the global defense community reassess China's systemic capabilities and strategic resolve in developing high-end military equipment. This endeavor transcends mere radicalism or recklessness. It represents the inevitable culmination of multiple matured factors converging at the right moment. First, this achievement stems from decades of continuous tracking, research, and accumulation of aircraft carrier technology and operational expertise by the Chinese Navy. From the introduction and retrofitting of the Liaoning to the fully indigenous design and construction of the Shandong, and now the Fujian equipped with electromagnetic catapult technology, China has completed substantial technological advancement and talent development in core areas such as overall carrier design, specialized steel materials, aircraft carrier compatibility, and combat system integration. The success of the Fujian carrier, in particular, demonstrates China's command over top-tier carrier technologies like large flat decks and electromagnetic catapults. This accumulated expertise means the carrier platform itself is no longer an insurmountable barrier for Chinese engineers. Second, this represents a direct manifestation of the explosive growth in China's high-end manufacturing and shipbuilding capabilities. The world's largest shipbuilding capacity, globally leading mega dry docks and gantry cranes, mature modular construction techniques, and a comprehensive supporting supply chain, these hard assets provide a solid material foundation for constructing 100,000-ton class vessels. With mature and reliable solutions already in place for the majority of the carrier's construction, including hull fabrication, outfitting, and piping installation, the primary technical risks of the entire project are now highly concentrated on the nuclear propulsion system. Integrating a new technology into an already highly mature and reliable construction system and platform design makes the risks manageable and significantly increases the likelihood of success. Moreover, China's deep-rooted expertise in nuclear energy technology provides cross-disciplinary support. Although naval reactors and civilian nuclear power plants differ significantly in design philosophy, power density, compactness, mobility, and safety standards, decades of fundamental research and applied experience in nuclear fuel, materials science, thermal hydraulics, radiation protection, and safety control have undoubtedly created a valuable knowledge base and talent pool for naval reactor development. Moreover, decades of safe operational experience from China's nuclear submarine fleet offer invaluable reference points for the management, maintenance, and safety design of nuclear propulsion systems for surface vessels. Thus, the emergence of the Type 004 aircraft carrier represents a meticulously planned, long-awaited demonstration of strength. It signals that the Chinese Navy no longer seeks merely to catch up, but aims to establish its own global benchmark and the ultimate symbol of naval power, the aircraft carrier. Its massive dimensions translate to more spacious flight deck operations, greater hangar capacity, and enhanced sustained combat capabilities. Its nuclear propulsion core grants virtually unlimited endurance, enabling prolonged forward deployment, high-speed maneuverability, and stable operation of high-energy weapon systems. Once commissioned, this colossal vessel will fundamentally reshape the balance of power across the Western Pacific and beyond, granting the Chinese Navy genuine capabilities for sustained, far-reaching operations, continuous presence, and formidable deterrence. Of course, challenges remain ahead, from the reactor's initial installation, testing, and integration, to achieving seamless coordination with all ship systems, and ultimately forming a complete nuclear-powered carrier combat system. A lengthy and rigorous cycle of trials and training still lies ahead. Yet the keel of the Type 004 has been laid. Every welded steel plate echoes the resolute strides of a maritime power advancing into the deep blue. This satellite image, unexpectedly revealed by Japanese media, may have prematurely lifted a corner of the curtain on a new era. On the competitive stage of aircraft carrier development, a new top-tier player is stepping into center stage with speed and boldness surpassing external expectations.